Hi all, welcome to the fifth part of the video lecture on transaction management. See, the part 4 we discussed about the concurrency control protocols, particularly the protocols which are using the concept of locking, and we particularly focused on binary locks. Okay, now let's see a different variation of lock called shared exclusive locks or read-write lock. See, basically what is the problem with the binary locks? The preceding binary lock scheme is too restrictive for database items because at most one transaction can hold a lock at a given time. That you know, right, how binary lock is working. So whenever a particular transaction want to access a data, so let me use the term access. So access, I mean, it can be read or write. Okay, so whether it is a read access or write access, we will be locking the data and we will take the data. I mean, we will access the data. And after the complete access, we will be releasing the lock by unlock operation. So this is what happened. But you know, what about the read operation? Actually, when it comes to read operation, if more than one transaction are trying to read on a common data, it is actually not a big issue, right? So many people can read data simultaneously. It's not going to create any issue. But read and write is typically creating problems. So the same thing you might study in operating system everywhere. Whenever we have shared resources, many people trying to access, particularly read access the shared resource, it's not going to create any issue. But someone is trying to modify the data at the same time someone else is reading it, whether he is reading it before modification or after modification, like that it will create issues. Similarly, two people trying to write the data at the same time. So read conflict is actually not there, right? So read write is conflict, write read conflict we have, and write conflict we have, but any number of read you can allow actually. So that is something not there when it comes to binary lock, and it is too restrictive, means it is treating both read as well as write operation in the same way. And for even though it is read operation, only one transaction can do it at a time, right? If other people are trying to read it, they have to wait. This is how the binary lock working. But now we have a better version of lock. Okay, so so that is based on the concept like several transactions can access data, access the same item X if they all access X for reading purpose. So if it is reading purpose, we can allow many transactions to access the data simultaneously. So we have to take this into consideration, and accordingly we have this shared exclusive kind of locks. So this is because read operation on the same data item by different transactions are actually not conflicting, right? So read write read write, they are conflicting operation. Read is not a conflicting operation. Okay, so however, if a transaction is to write an item, it must be exclusive. So that access should be exclusive, right? In the sense, if it is write operation, you should allow only one transaction to do it simultaneously. You should not allow any other transaction to write or read. Okay, so that should not be allowed. Only one transaction exclusively should access the data. So that is why it is called exclusive lock. But read lock is typically shared. That means multiple people can read lock a data item and they can access the data. Fine. So accordingly, we have this shared exclusive or read-write locks. They are three, where there are three operations. What are all the operations? So if you want, you can lock a data item for the read purpose. So that is our read lock operation, and we are locking some data item for write purpose, and we are unlocking the data item. So like that, we have three major operations, and all three operations we will discuss shortly. Now a lock associated with an item X, as before, lock of X says that what kind of lock we are having, whether it is read locked, write locked, or it is unlocked. So like that, it could be a flag kind or a variable. Okay, so lock of X indicates what kind of lock this particular data item is holding now. A read locked item is also called as shared locked. Why? Because when it comes to read operation, many people can read the data simultaneously, or the data item is being shared by that particular lock, right? So we will allow multiple transactions to lock the data in a shared basis if all are trying to read the data. Where write locked items are exclusively locked, because only one can lock the data item for the write purpose. We will not allow others. So it is exclusive lock, where read lock is shared lock. Fine. So that about it. And so now whenever you are looking at any data item, now the item is having a record structure like what is the data item name, what kind of lock it is having, Okay, read lock, write lock, or unlock accordingly. So if it is read lock, it is shared, right? Many people can read lock the data item. For corresponding to that data item, you can keep something called as number of reads. So how many reads are happening on the data item at that point? Okay, so that variable you can keep. And who is the locking transaction? So when it comes to write lock, there is exclusively a single transaction that will be the locking transaction for the data item. But when it comes to read lock, there will be a number of transactions trying to lock the data for read purpose in a shared manner. So this is a list, right? So the locking transaction is for write lock, and for read lock it is locking transactions. It is plural. It is a list, right? So the system maintain something like this, but actually it is enough to maintain this data record only for logged item. For unlocked item, we don't have to fill. So typically in a log table we are keeping it. So if you are keeping an entry for unlocked item also, its size will be huge. So if you want, you can optimize it by keeping an entry in the log table only for the logged item, whether it is read logged or write logged. Now suppose it is if you are looking at the status of lock of X at some point and you are getting it as write locked, that means only a single transaction can write lock the data, right? This is exclusive, where if the lock status is read locked, there will be a number of transactions in a shared basis lock the data, and the list of all transactions we will be maintaining here. Okay, in case of write lock, only one transaction will come here, right? In case of read lock, a list of transaction trying to read that data item will be coming here. And you know, whether it is a read lock, write lock, or unlock operation, all those operations should be indivisible. We will explain how these operations are executing, and you have to keep in mind it should happen as an atomic unit. Okay, so there should not be any interleaving in between. If that is the case, indivisible or non-interleaving is what we are supposed to maintain. Otherwise, it will not guarantee the outcome as expected, right? So that you have to keep in mind. So this is how you can explain the operations read lock, write lock, and unlock operations, starting with the read lock operation, and it's very straightforward. What you have to do? First, you have to check the status of the current lock status, right, for the data item. If lock of X is equal to unlocked, that means no one is, it's just free, right? No one acquired this particular data item and it is freely available, so that I can lock it for read purpose. So I am making that lock of X as read locked as a status. I am modifying, and this is the first transaction trying to lock the data, right? So it is unlocked already. So the number of reads you can initialize to 1. Else if it is read locked, that means I am trying to read lock an item, but it is already read locked. Now reader, there is no conflict in the sense you can allow that transaction also. Now you don't have to update this lock variable, because this step you don't have to execute because it is already read locked, right? The status of lock of X will be read locked. Only thing that you have to do is you have to just increase the number of reads. So now this is a new transaction trying to read the data. So how many reads are already there? +1, like that you can update. Now else means the third case, it is neither unlocked nor read locked, so definitely it will be write locked, right? In that case, our transaction is supposed to wait because it is already write locked by some other transaction. Write read is a conflict. Okay, so this current transaction has to wait until the lock of X is unlocked. Okay, so status changed, and the lock manager wakes up the transaction. So okay, so it will keep waiting, otherwise it will go back to that label B. Okay, so and it will come again, means it's kind of continuous polling kind of thing is happening until the lock status is unlocked. Similarly, how we can do write lock, it is again straightforward. If the lock status is unlocked, you can simply write lock the data. Otherwise, you have to wait. Here there is nothing like this line is missing here, right? Something similar, because here it is exclusive lock. So there is only two possibility: either lock the data or wait for the data if it is already locked. Fine. So this is how this read lock as well as write lock operations are executing. And now once all the transactions finishes, they can execute unlock operation, right? So unlock itself may be from already the data item may be write locked or read locked. This unlock is something common for both. Okay, so what you have to do, you have to check this current status of the lock. If it is already write locked, you can make this unlock by making lock of X is equal to unlocked, because write lock means it's exclusive, right? Only one transaction will be locking the data, and you want to unlock it also. Unlock it in the sense you will just make the status lock of X as unlocked, that's all. And you can so wake up one of the waiting transaction. The transaction which are trying to access same data maybe for read or write purpose might be waiting somewhere, right? So typically we will maintain a queue, waiting queue for making all transactions wait. And from that waiting queue, you can wake up one of the transactions, say, which is having higher priority as it is queue first in first out manner, right? The who is in the front, that you can wake up and he can continue like that. So now that about the write operation, I mean, if it is already write locked, this is how you can unlock the data. Now if it is already read locked, so now it is important, because read locked I want to unlock in the sense there may be other transactions simultaneously read lock the data. So simply you have to decrease the number of reads that particular variable only. So if 5 transactions are simultaneously reading the data, number of reads will be 5. Okay, so and when one transaction want to unlock the read lock, it just makes a number of reads as 4. That means already 5 are there, now only one is leaving. So only 4. Then next time another transaction wind up, number of locks become 3. Then number of locks become 2, 1, etc. 0. So when number of locks is equal to 0, that means only one transaction was holding the data. And when you decreased that number of reads, now it becomes 0. That means now no more transaction, right? So after decreasing, if the number of reads is you are getting a value 0, means currently there is only one transaction and that is not in the picture. It is means its read operation is over, right? So you can simply make that variable completely free by putting lock x is equal to unlocked, and you can wake up some other transaction who is waiting for the data to lock it. Okay, so wake up that you can do with the help of that waiting queue or something. Okay, so this is how this locking as well as unlocking is happening. And now if you are looking at the shared lock, some of the rules, right? So just like in the binary locks also we saw the rules, and the rules are just straightforward rules. Okay, so that you have to obey. So the first thing is, of course, a transaction T must issue a read operation or write operation, I mean write lock or read lock before any read item. So read item is actually we are trying to read an item from the database. So before that you are supposed to execute either read lock or write lock. Both are fine. So typically for reading purpose we will be executing read lock only. But even if you are write locking the data and you are reading, there is no issue. But if it is a write operation, definitely you have to write lock the data, because write lock is something shared, not shared. Write lock is something exclusive, so that others will not get access. But read lock, as it is shared, even though you are making it as write lock, simply that sharing will not happen. That's so the locking will happen, fine. But if you want to access the data for the write purpose, so or you are going to execute write item, before that you have to execute write log on that item. Okay, so that is important. Now after completion of all read as well as write operation, you have to unlock it. That is third step. A transaction T must issue the operation unlock after all read item and write item on this data item X are completed in that particular transaction. Now what is the fourth step? A transaction T will not issue a read lock operation if it already has a read or write lock. Already it is having, it locked the data maybe for read purpose or write purpose, and it is trying to lock data again, say for read purpose, that is not allowed. And similarly, already the data is having read or write lock and it is trying to access the data again for the write purpose, that is also not allowed. But except two cases, say sometimes you want to downgrade the lock and sometimes you want to upgrade the lock. In these two cases, these restrictions are not there, and we will see what is downgrading of lock as well as upgrading of lock soon. Okay, so these two are exceptions. Otherwise, you know, you are already locked something and you are trying to lock it again, that is meaningless. So you are not going to allow it. So that is what this step number 4 and 5 is saying. But there is something called as downgrading of the lock as well as upgrading of lock, that we will see. So which is an exemption. Now the last step is like, I mean, rule of thumb is like a transaction T will not issue an unlock operation unless it already holds a read lock or a write. So I am issuing unlock and I don't have any lock with me, so that is meaningless. Okay, suppose I already locked an item for read or write purpose, I can simply execute unlock. Okay, it is fine. Otherwise, don't issue such an operation. This is what these rules are saying. They are normal, straightforward rules only. And in between we saw two exemptions for downgrading as well as upgrading of lock. So this says that suppose I am having, I logged a data item, so for the write purpose, okay, I logged it. Later on I want to read log the data, because now you know I already have the data item and I already have the data item and I read log the data, and later on I want to write log the data. So this is situation, read to write. Okay, so initially I log the data for the read purpose. Okay, maybe it executed and it is over, and at some later point the same data item I want to write log, but before that I can unlock the data and I can separately execute write logs. That is fine, but instead of doing unlocking and write logging it again, why don't you upgrade the log, right? Because read operation is something shared, and from that when you are making it exclusive, it is upgrading, right? So you are giving it a better status like that. Okay, so when it comes to what I can tell, exclusive log, like a write log, you know, it is getting some VIP privilege, right? So no one else can access the data, and shared means many people can share it. So always the promotion of the log, say from read log to write log, is what we call as log upgrading. Similarly, suppose the item is already write logged and you want to log it for the read purpose. Anyway, it is there, you can read it also, there is no big issue, but it is always better to downgrade the log status from write log to read log. So if you want to change the log status from read log to write log, say shared to exclusive, it is what is called upgrading of log, and you want to change the log status from write log to read log, or shared to exclusive to shared to a lower status, that is called a downgrading. Okay, so these two operations are permitted. So that is but you know, when it comes to the general rule of thumb, we will not allow read or write log an item once it is already logged, but here from read to write, that upgradation is possible. Similarly, from write to read on a common data item, that downgrading is also possible. Other combinations are not allowed. Okay, so that about it. Now what about our two-phase locking protocol? Anyway, we will discuss this two-phase locking protocol in the next video lecture. So we can wind up this session right now, because here we exclusively explained that shared as well as exclusive lock, and how these operations are being implemented. That is what we gone through, and finally this downgrading as well as upgrading of the lock operation. Now based on this, we have a typical protocol called the two-phase locking protocol, which is proceeding in two different phases of locking as well as unlocking. So that we will discuss in the next video lecture, and some of its variations also. Yeah, thanks for watching.